have seen projections now for 30 years, and they're largely correct, but in fact they are underestimating the impacts of climate change. The modeling, the work with actually putting all our observational information and data into models that are capable of predicting the future, that is really the bottleneck for our improvements in science. And this is something that we can do here. In some ways, you might say that it's depressing to stand here as a scientist saying the same thing we said 30 years ago, and now we realize the impacts of climate change is in fact happening. It is only through the long-term data that we can actually see changes. It's only through documenting decades on end of ecosystem behavior that we can see things are changing. It's also through that we can see extreme events, which is also predicted to be more frequent. So we need the possibilities as we have here to work and compare numbers between here the northern boreal zone with the high Arctic, as we have the data from in Greenland. Through those comparisons of long-term data, that's where we can see change, and we are seeing change.
So some examples, like this is one, what could be done from the ground penetrating radar.
We've seen presentations that come in from different perspectives, but all looking at the same area and all concerned with some of the same questions. So we've seen a free playground for discussion, and we're also making connections here with arts and with how we are communicating science. So I think we've had a fantastic time here.
Does no manipulation happens at each plot, so that we have
come and teach your students here, use the data that we can provide, and that we can offer the opportunity to go out and collect here, and then take our possibilities also for using databases that we are making available from elsewhere in the Arctic. It's a fantastic opportunity.
Here we have a rich experimental setup where we are measuring CO2. Here with the ecovariance we have also about 36 plots where we are manually measuring methane emissions. We are experimenting with a couple of automatic chambers also measuring methane emissions.
Basically this part here, this is, at least in Greenland, it's a very fast process.
Okay, so it's like...
So this is really extremely fast. So
I've worked a lot with data from Greenland, so I focus on carbon exchange dynamics in two sites, Kobefjord and Sakkenberg. So even though they are quite far from each other, there are quite interesting differences. For example, Sakkenberg is located 10 degrees more northern than Kobefjord. Even with colder temperatures and shorter growing seasons, this ecosystem has been a net sink of carbon way more strong than Kobefjord. So this was associated with higher nutrient availability. So that was a quite interesting finding. And what we are trying to do here in Oulanka is to include new data to compare a boreal site versus our sites in Greenland, both in low and high Arctic. We are working in a very challenging environment. Of course, we have plenty gaps in data. We cannot measure variables all the time. So it comes quite handy to have ecosystem models to fill gaps in data, in knowledge, and also in order to be able to forecast processes in the future. The ecosystem models are the only tool available.
The processes which happen during the climate change are not yet well known in groundwater surface water interaction, for example, and these should be studied further. After the workshop, it seems highly relevant to study puukkosuo in more detail. So it's important to understand physical and chemical processes happening in the peatland in order to understand gas exchange measuring results of the puukkosuo. We'll do additional geophysical surveys in puukkosuo and build a 3D structural model of it. And in addition to that, we are going to study the peat hydraulic properties, peat type, and geochemical properties of the peat and the peat pore water to support the gas exchange studies there. So we are interested in to understand what kind of geochemical background the bedrock gives to the study area, what kind of soil deposits there are on the top of the bedrock, what are the groundwater resources and how they are connected and in interacting with peatland, ditches, ponds, river and other surface water bodies.
So I think one of the biggest problems with climate change is biodiversity loss. And we should be really focusing not only on the organisms we can visually see by bare eye, but also on the microscopic organisms below ground, so the microbes. And then also on the microbes' functions, so that we are losing a lot of microbial diversity and then also functions. And those microbial functions can be crucial, for example, in methane cycling. So I think that is something that is a big question and that we should be focusing more.
Eli nämä klorofleksit ja aktinot. Ja nämä aktinot on just niitä, mitä on sellaisia happamien maiden lajeja.
For example, in Oulanka, we are working at the grazing experiment. So what kind of effects does the grazing have on those microbial communities? And in addition to the microbial community composition, we are also working on microbial activity. So we want to understand that which microbes are active and in which conditions. And more, we want to know that what kind of functions those microbes carry, that what kind of metabolic processes they are processing at different conditions. For example, the processes related to methane cycling. It was really great to meet all those people working in Oulanka at the same sites, tackling with the same kind of problems and same kind of research questions. And so there are a lot of new ideas, and I feel that we should meet more often, that it would be great to meet everyone who was at Oulanka or is doing research in the future in Oulanka annually. So I think that is really important, that we meet and we get the chance to brainstorm together instead of just sitting on our own computers in own locations.
Hyvä pointti.
Future looks very bright, although there's a lot of work to be done. But now we are entering the phase where these different groups are joining forces. Next year, Oulanka will enter the process of ICOS labeling, which means that Oulanka will become an ICOS site sometime in the future. And this holds great promise because ICOS is about standardization of greenhouse gas data. And by following that protocol, we will ensure very good quality data for the purposes of modeling, understanding of carbon dynamics, and so on. We are now also part of the Global Life Plan project, which is one of the major projects of our time in terms of biodiversity. We as a humankind or population of the planet have pretty much failed to answer our own call so far. We haven't been able to reduce emissions nearly enough, and I see that as a very alarming kind of prospect for the future. We're not doing enough. The work we do here at the EcoClimate System and Oulanka Research Station in general produces exactly what is needed to understand the future changes. We provide prime data for modeling purposes so that we can actually estimate what's going to happen in these different model scenarios. It looks like we have a really good group working together with quite many people from different countries, different branches of science, but it's also clear that we need even more people. So, welcome to Oulanka.